Okay guys, today I'm going to share with you something that you probably haven't seen before on YouTube. I'm going to do the liquid rust removal and I'm going to evaluate the most common acids that you can find out there. And we're going to go from nitric acid, 65% concentrated. And then we're going to look at acetic acid, the main component out of white vinegar. And I'm going to then take you to phosphoric acid, concentrated here, which is the common component in rust eaters. Here you can see rust eater that they sell in the car shops for removal of rust. This is a highly diluted version. This is actually, as you can read up here, is 21.25% concentrated. What you see over here is 100%. Well, 99 it says. And then we're going to go over to the hydrochloric acid, which is 37%, as concentrated as it can be, and the sulfuric acid, which is 98%. But before I actually continue this video, I'm going to tell you a little bit how we will have to set the standard, because this one, as you see over here, says 98%. How can we compare that to something which is 37%? Or for example, this one is 100%. I mean, this is as concentrated as it gets. So I'm going to normalize these ones to the same concentration level. So to make this comparison as accurate as possible, I have calculated that I should use approximately 30% of concentration of these different acids. And this is based on the fact that this hydrochloric acid, which is a gas, it can only be dissolved at its maximum at 37% in water, while you have 98% on a water solution over there. So this is mostly pure acid. You can actually feel that also if you lift them. This entire bottle, well, it's only actually half full, but it weighs much less than this bottle. It's really heavy. So I'm going to dilute it down to 30%. This is going to be diluted down to 30%. This is going to be dissolved 30%. This is acetic acid, which is 99.7% pure. This is going to be dissolved down to 30%. Now in white vinegar you have about 5%, so we're going to have 6 times higher concentration of acetic acid than you have in white vinegar. And then we have nitric acid over here, which will also be dissolved down to 30%. So to evaluate our experiment, I have these railway nails, and here you can see one which I already removed the rust on, and here's another one which will be used in today's experiment. And by measuring the thickness of this one were taken at the same place and then been sitting in the ground for about 20 years, I can tell that there's about 1 millimeter of heavy rust until you get down to the pure iron underneath. Now, before I continue, these are very strong acids, and there are rules for how you mix acids with water, because these acids react with water. So you need to have full safety awareness when you work with these strong acids. And I know that these acids, many of them, you can get hold of them in the hardware store or in, depending on which country you are in. And but you need to be aware of that they are dangerous acids, and some of these acids, if you mix them, they're able to dissolve pretty much everything, including gold. So look up the rules. First rule when mixing acids is you mix the acid into the water. The reason why you don't mix the water into the acid is because it reacts so hard with the water. So if I would pour water into this acid, it would basically react explosively. It would bounce off the surface, and in worst case, somebody or you would get it in your eyes. So you always mix the acid into the water so that the water can take up the energy and the heat that is formed when the acid and the water reacts. Having said that, always work with gloves, eyeglasses or safety eyeglasses, and in the ventilated area, and never look down into your mixtures. Well, it's so reactive, so now it's so hot, so I can hardly hold the beaker. And I think you may be able to see the water coming out as steam, because we're approaching 100 degrees Celsius. So I will now let this sit, and I will let it cool down to room temperature, so all the acids will be room temperature when we start the experiment. Now we have them all lined up, and we have from the left we have the Sulfuric Acid, and we have Chloric Acid, Hydrochloric Acid, Phosphoric Acid, Acetic Acid, and Nitric Acid, and they're all diluted, so they are 30% concentration. So now we only have left to start the experiment. So we will start with just checking now the pH of the different acids. And here we have the Sulfuric Acid. And the pH is below 1. Then we will move on with the Hydrochloric Acid. And also here the pH is below 1. Then we take the Phosphoric Acid. And also this one is below 1. Go for the Acetic Acid. Also this one, well, this one is about 1. Marginal difference. And the pH is below 1. And then I will slowly immerse each one of the railway nails into the acid. And we will start with the Nitric Acid to the right. So we can see there that there is no immediate reaction going on. But as I look at it now, we can see that bubbles start coming off. Then we take the second one here, which is the Acetic Acid. This is the acidic component in white vinegar, but it's 6 times as strong as in white vinegar. And we can also here see that bubbles are starting to develop on the surface, dissolving the rust. We move on to the Phosphoric Acid, which is the main component in the rust dissolvers that you buy in the auto shop. Few bubbles are created, very small. Now we're going to try out the Chloric Acid. Wow, this one is very fast. Immediately as I immersed it, flake starts falling off, and the acid changes color. It's becoming yellow-brown. And now to the last one, Sulfuric Acid. This one is also very efficient. So lots of bubbles coming off, considerably more than for Nitric Acid, Acetic Acid and Phosphoric Acid. There's a bit of different time start here, but they were all immersed during the time course of 5 minutes. And what we see, the Nitric Acid solution is also starting to become yellowish, greenish. And this is the iron going from the rust into solution. Acetic acid although bubbles are formed, it doesn't change the color yet of the solution. And the phosphoric acid, it actually seems as the bubbles are not that active. Formed a lot in the beginning, but then they kind of stopped. And for the chloric acid we have still bubbles forming. A lot of iron goes into solution. It's the fastest progressing at this point, although it's the bubbles are very small. And on the sulfuric acid the bubbles are large, and there's a lot of them forming at the surface. So we will have them sitting here now, and I will keep them here. It's past 7 minutes. I'm going to come back and I will inspect them at 15 minutes, at 30 minutes, and at 1 hour. Now been 15 minutes. We will do the first inspection. So here's the nitric acid. What we see is that the bubbles are still forming. I shake it a bit. Some pieces are falling off and the solution has turned yellow. For the acetic acid, bubbles are forming, but it's not as much as on the nitric acid. And the solution is still transparent, meaning that not much iron is being dissolved. Phosphoric acid, shake it, some flakes falling off. The solution is slightly brownish, but after 15 minutes it's actually mostly transparent. And this is for a solution that is stronger than what you buy as a rust eater in your car shop. Now we take a look at the hydrochloric acid. And here we can see that there's a lot of progress. It's actually falling off. Flakes inside there, and it's been dissolving so much rust that you can't see through any longer. Then what you see is that basically all the rust is gone. There's some stuff sitting on the surface. What you see here, that's pure iron that we see over there. I'm going to put it back, and then we will check the sulfuric acid. Here the solution is muddy. I'm going to take it out. Bubbles are forming continuously. And on one little spot right over there I can see iron. Right there. Most of the rust is intact. Or not intact, but still present on the railway nail. So we'll keep going for another 15 minutes. So we're now at 30 minutes, and this time we will take a little bit of time to actually look at what's happening. So we're going to start with the nitric acid, and I'm going to stop the reaction. First we're going to take a quick look at it. It's still bubbling. I can see a few flakes falling off there on the bottom there. I don't know if you see that. And the solution has changed color. So iron is definitely being dissolved from the rust here. But it's not super fast. So I will just take it up now. And I will put it down into distilled water. That way we stop the reaction for a moment. And now I'll try to poke in this a little bit so we can see if there's any loose rust coming off. And the rust is still solid here, although you can see from my fingers something brown is coming off. There's nothing, well, a slight tendency of being discolored like dirty water, but there's nothing actually showing any green, which is synonymous with ions from the rust. Stop the reaction. We will look at it. Still plenty of solid rust, and it's much firmer as well as compared to the one treated in nitric acid. I'm going to run my fingers on it. Yes, some of it comes off, but there's no massive reaction going on here. It's going slowly. So now we're going to inspect the one that you can buy in the hardware shops as a rust removal. This is the phosphoric acid. You can see it's actually a little bit brown. Some flakes are on the bottom. Poking it. Still solid. There you can see one. Pieces of rust. We have entire coverage here of rust all over. Not much has happened. I'm gonna run my fingers on it. There's not much coming off here. About the same as the acetic acid. So acetic acid and phosphoric acid are about similar. Not very fast. Now we're going to take the chloric acid, and as you can see, the entire solution is now there. Well, there you see the name coming out. So it's bubbling very, very strongly. Bubbles are basically formed all the time, and now they're much smaller and even. It's like an even flow coming off. We'll take it up. Poke in rust. Wow, there's no rust left. A little piece there, and a little bit down there. But as you can see, it's like entirely cleaned off from rust, and this is after 30 minutes of reaction. A little bit of brown coming off that part on the bottom. I think you see clearly now how efficient hydrochloric acid is in rust removal. It's almost already done. And we will move on with the sulfuric acid. Bubbles are formed, a lot of them. Also a slight tendency for having smaller bubbles here. And yes, there is this little section over here shows iron. Actually also some there, and here is a big piece of rust that has fallen off. There's no marked line like we have in the hydrochloric one up here. I run it on my fingers. See? Yes, there's a lot coming off here. You see, I become completely dirty. So we can almost now, at this point, rate them. I would say that the strongest rust remover is the Hydrochloric Acid. The second strongest one is either the Sulfuric or the Nitric Acid. And then comes the Phosphoric Acid and the Acetic Acid. But we will keep on watching, and we will run this now and stop next time at 1 hour mark, and then we will evaluate again. We are approaching 1 hour now, and just shake them a little bit. And there we go, this is 1 hour. Now I will terminate this experiment. And I'm just going to transfer them over into the respective bath. And the nitric. And as you can see from the solutions, it appears like the hydrochloric was most effective. The second one was either the nitric or the sulfuric one, and then the phosphoric one and the acetic one. Well, it seems like the sulfuric one is slightly more brownish. You can see I can shake it around a little bit here. And there's also some flakes still left in that one. Whereas the nitric one is a little bit more green. Also some flakes in that one. If we take a close look at them under the light, the sulfuric acid appears to have dissolved a little bit more than the nitric acid. So now let's take a look at the nails. And here you see all the nails right next to each other. Now I neutralize the acid so I can hold them. It's not acidic anymore. But you can see from this one, there we see the iron coming out. That particular spot over there. So now all I get on my fingers is just rust, and the rust seems to be somewhat loose. Maybe I can scrape off some, but there's definitely a lot of rust here which is still intact. Wow, look at this. It's all removed. I will take the phosphoric one. Still pretty much intact, but I'm sure since the solution actually became slightly discolored, some of it has come off, but as you see it's very little. Now we move to the acetic acid one. Here it's actually limited how much is coming off. It doesn't come off so much on my fingers. This has been the worst performer, definitely. Acetic acid, although 6 times as strong as in white vinegar. Finally, here is the nitric one. Nitric acid. Well, you see, some of it's coming off on my fingers. So but it's not all the way down to the iron. So at this point we can say clearly the winner is Hydrochloric acid. The loser is the acetic acid. Second place, sulfuric acid. Third place, nitric acid. And fourth place is the phosphoric acid. Now, if you are a chemist, then maybe you have access to something like this. In this book we can actually find out something called the Pka values. That's basically how reactive the different acids are. So, from tabulated data, I can then find in the book that the Pka value for the winner is minus 6.3. For the second place, minus 3. For the third place, the nitric one, minus 1.64. For the fourth place, 2.50. And for the acetic acid, the loser, it's 4.76. So by only knowing the Pka values, minus 6.3, minus 3, minus 1.64, 2.15 and 4.76, I can know from the beginning which acid is going to be the most reactive. And the lower the Pka value, the more reactive the acid is going to be. So then, by looking at the tabulated data, I wouldn't need to do this experiment. Well, thanks for listening. I hope you enjoyed this. And for your rust removal experiment, now you know which acid to pick. Have a good day. Finally, here you can see all the rusty nails as they come out after the reaction. And they are put in the same order as we had them in the laboratory cupboard. And it appears that it's a little bit dull in the surface. But if I take a tool and I sand it down for a little bit like this, then you can see the iron coming out as shiny. Now if we look at the sulfuric acid, the one that ranked in as the second most efficient, then we can see over here that some flakes came off, and obviously there we can also see the metal coming out. But you also have areas like this where it's still a lot of rust, where it's coming off as flakes, and those ones are still intact. We have not dissolved this entirely. If we move to the one that is in third place, then we have this one. This is the nitric acid, and the nitric acid, well, here you can see a piece has come off, but you can also see how much rust we removed, because if I, there it came off, it was a substantial layer of rust on these railway nails. Here you can see it properly, it's coming off. It's about, well, it's a little bit more than 1 millimeter. As I said in the beginning, it's about 2-3 millimeters of rust that we have removed. And then we have the phosphoric, which came in the fourth place. Here it's still a little bit wet, but well, there's all the rust. Well, we have removed a lot of rust, but all of it is, yeah, there it came off a flake. You can see, but we're still not down to the bare metal. And the acetic one is, some pieces are coming off, but there's a lot of rust left on this one. Now if you would use acetic acid with heat at the same time, it would be much more efficient, but you can also choose the right acid from the beginning.